So in this chapter or section 10, we'll learn about the tension force. This is chapter 4. So here we just have tension force, which is just forces often applied by cables or ropes. So let's say we have a box and it pulled to the right, then that it's the tension. And Newton's third law states that there is an equal but opposite reaction. So if the tension points to the right with a certain amount of force, then that same force will point to the left negative though. And then we have the concept of massless rope. And we have this concept because Newton's second law of motion states that a net force is required to accelerate an object with mass. So if there is no mass on a rope, then that means there is no net force. And that just makes it easier for us to attain the net force of the box. Okay, so now for some concept questions. This concept question states that a rope is used in a tug-of-war between two teams of 5 people each. Both teams are equally strong, so neither team wins. An identical rope is tied to a tree, and the same 10 people pull just as hard on the loose end as they did in the contest. So keywords are identical rope, equally strong, and they pull just as hard in both situations. So in both cases, the people pull steadily without jerking, which rope sustains a greater tension. So in the first situation, we have people pulling on both sides, so I just kind of drew 2 people, and each pulling with 5 newtons. And in the second situation, we have the same amount of people pulling with the same amount of force, but together to one side. So which one has a greater tension? Well, in the first situation, the tensions actually cancel each other out because they're pulling on opposite sides. But in the second situation, they add to each other. So if each of them were 5, then they would have a tension of 10. So the answer would be that the second situation has a greater tension. Okay, so starting with some problems. This round states 3 forces act on a moving object. One force has a magnitude of 80 newtons and is directed due north. Another has a magnitude of 16 newtons and is directed due west. What must the magnitude and direction of the third force such that the object continues to move with constant velocity? So 16 newtons actually should be moved upwards to draw this correctly and to show the real magnitude, and the magnitude would just be the hypotenuse of this triangle. So to find the magnitude, you just do the square root of 60 squared plus 80 squared, which will just be 1 times 10 to the second newtons, and the direction will just be the tangent. So it would be 60 over 80, which would give you theta as 53 degrees north of west. Okay, so in this second problem, we have the drawing shows a wire tooth brace used by orthodontists. The topmost tooth is protruding slightly, and the tension in the wire exerts 2 forces, T and T, on this tooth in order to bring it back into alignment. If the forces have the same magnitude, 21 newtons, what is the magnitude of the net force exerted on the tooth by these forces? So what you'll notice is that because the x exponents of these tensions are opposite each other, then they will cancel out. So the x components are not really important in this case, just the y components, because they're both facing downward. So here I kind of drew the free body diagram, so the 2 tensions are being shown. Their x and y components, and again their x components will cancel out, therefore they're not important. But we do know we can find the y components, so we just do negative t sine of 16 of both, which is negative 5.78, and to find the total net force, you just add these y components together, which will give you negative 11.6 newtons. Okay, so this problem states part A of the drawing shows a bucket of water suspended with a pulley of a well. The tension of the rope is 92 newtons. Part B shows the same bucket of water being pulled up from the well at a constant velocity. What is the tension of the rope in part B? So we know this is, again, an equilibrium, meaning that their normal force and their weight has to cancel out. And because this is the same bucket with the same exact weight, we know that the normal forces are the same for the bucket if the weight stays the same. So we kind of already have this question solved, but let me show you how you get that. So you have the two forces, 92 newtons, and the weight of the bucket, and we know that the two forces added together is 184 newtons, and this will also equal the weight of Fg. And in part B, in the part B, we have the same exact bucket, and this is the key word, same bucket, because if it is the same bucket, that means their weight is the same, and that also means that the normal force is the same because it's an equilibrium, and the normal force and the weight have to cancel out, so the weight and the normal force are equal to each other, and again, the answer is 184. Okay, so the last problem states the steel I-beam in the drawing has a weight of 8 kilonewtons, remember to change that to newtons, and is being lifted at a constant velocity. What is the tension in each of the cables attached to its end? So they want each of the cables, they don't want the net force. So kind of to draw the free body diagram, we have the two tensions and the 70-degree angles. To find tension 1, just draw as a right triangle and just put a line down the middle of that triangle, and it's just t cosine 70 degrees and t sine of 70 degrees. So you just find the component form of t1. You do the same thing for t2. And then, also remember that t2 is, the x is negative because it's as if you're looking to the left, so that will become negative. And also remember that it asks you for the tension of each cable. So in order to find that, you have to add these cables together, and notice how you end up with only the y component. So now, because you only have a y component, that y component will have to equal to its weight because of Newton's law that states equal but opposite force are being acted on each other. So that y component has to equal to 8 times 10 to the third, to the third newtons, and you end up with t equals 4,260 newtons.